Welcome everybody to Sustainable River Basin Management Module 4.1, Part 1. Let's first reflect on what we have been doing so far. We have completed Module 1, 2 and 3, and we are now moving into Module 4, dealing with sustainability in river basin management. It will cover 2 weeks. We start today with week 1. Let's first think about our topic towards sustainability in river basin management, which indicates that I will present you a number of tools and recommendations and guidelines, but there is no such final recipe for appropriate sustainability management as yet, for which I can present to you. Now, let's remember that all depend on one and the same hydrological cycle, all depend on one and the same hydrological budget, including water quality. And this results in numerous negative externalities, such as social, economic, ecological, but also intergenerational externalities. And there are a number of attempts of solutions. Again, there is no such solution that I can present you as the best working everywhere. That's why attempts such as supply augmentation, artificial recharge, water conservation, use reallocation, and many others. And this leads us to an increased conflict potential among the water users, which we also will be looking into in detail right now. Let's talk about the externalities in water resources use. What is meant by this term? It's meaning a constant redistribution of costs and benefits along lines of power, determining who are the winners and losers among diverse stakeholders. It means also a redistribution along spatial, temporal, and socio-political scales. So it's a redistribution of costs and benefits. Those occur when more powerful actors secure water at the expense of economically and politically marginal groups. This, just as an example, cities and industry may get a preferential allocation of water. An example here, in the case of India, water supply to municipalities is set to a minimum of 200 liters per day per capita, whereas in rural areas it is 55 liters per day per capita. And one could question that differentiation. Or the case of fishermen, which are often displaced as a result of water projects, construction of dams, for instance, and are very seldom compensated for the loss of their livelihoods. Let's try to understand these intergenerational externalities. Those occur when the cost of current consumption are borne by the future generations. And just remember of the cumulative effect of river basin closure or river basin stress. As it accumulates, it will be postponing the need for solutions and will postpone problems onto our coming own children, coming generations. Now, I've used the term closed river basin already, or stressed river basin, several times, and I think it's appropriate now to define this a little bit better, to what are our instruments and options towards sustainability in river basin management. Let's look into the open basin first and rivers under stress. We can say that river basin development is following a characteristic pathway from an open to a closed or a stressed basin. It's almost predictable to any river basin anywhere on our globe. What is an open basin? This shows us a typical hydrograph, the time scale here of one hydrological year, and then we have discharge here, water flow here. Whereas for that we have the dark blue, the total basin runoff, which includes groundwater flows as well. And then we have what is the surface water outflow from the basin, the blue line, and we have the lighter blue line here, which lighter blue volume area coverage here, which corresponds to a discharge rate volume committed outflow, the amount of water that's been allocated to certain water uses. And what we can see in this case is that we have still a certain amount of water that is not committed to any of our human water utilizations, which would be, for instance, available for aquatic systems. There's some water still reaching the sea or the ocean. Now, this river basin development is a gradual process. It's taking time. It's occurring along generations of people working on this river basin development. The changes in water availability are first hardly noticed by the local residents, whereby somebody coming occasionally to this region may first see and recognize that changes are indeed taking place. So it's a gradual process, and for that reason many may not pay too much attention to the changes taking place already. Now, when we look into a closing basin, which is the next step on this, we again have a hydrograph here which shows us the dark blue, including the light blue as our total basin runoff, and the blue line our outflow. And what we can see here is in the committed flow as the light bluish area here again. And what we can see is that our surface water outflow is tipping zero line here, so there's no discharge taking place during some periods of the year, and in some periods it is coming close to falling completely dry. And we can see that our committed, allocated water amounts cannot be provided. Water is not sufficient to be made available to those who have received a right or a permission or to receive that amount of water. That could affect farmers, for instance, who cannot irrigate their fields during this period, could not produce, or it may even force some factories to close down for that period of time when not enough water is available. So that increased pressure leads to a wave or an approach of trying to capture each drop of rain, a perception that each drop of rain that reaches the ocean still here may be a lost drop to those parts of the basin or those parts of the months which were underserved by water. The result will be that more water infrastructure to store water may be built, investments would go into this, and we are moving into a system trap. We come back to the system traps and how we can overcome them at a later point again. But this is a typical pathway leading to a trap. Now, looking into the final stage of this, the closed river basin or stress basin, which again shows us here our total basin runoff and our committed portion here, and our blue line shows us our surface outflows. Now, the surface outflow line, our hydrograph, has now substantially changed. First of all, we can observe these sharp peaks now, which indicate flash flood events. This is due to some changes in land use somewhere in the river basin, leading to a faster surface water runoff and leading to flood events, local flash flood events. And on the other hand, we have substantially lower mean annual outflow or surface outflow from our river basin. Although the overall total basin runoff, the physical conditions of rainfall have not changed. We also see that we have now several months, close to half a year, of dry spell occurring in this river, where the committed outflow cannot be guaranteed, where there can be no supply, no allocation take place, and for the rest of the year where we have still some surface outflow taking place, this is not sufficient it's half of what the committed amount would require to be satisfied. So there are several months, there's a substantial reduction outflow. This also indicates that there's a substantial groundwater over abstraction, and there's no amount of water left to flush or to dilute our pollutants, to remove our pollutants, and to sustain ecosystems which were also depending on the flow of the river. Now, what we can summarize from this is that basin development leads to an overcommitment, the degradation of rivers, a diversion, and a total control of the flow, a trial at least of a total control of the flows. It essentially ignores functions such as downstream needs, what is not available, committed in one stretch and overused in one stretch, then affects all of the downstream users. It also does not include aspects of outflow into the sea, which is essential from the point of view of reducing water pollution, and ignored is also anything like environmental flows. Now, this seems to be a trap out of which very few were able to lift up and overcome such situations. Major river systems, known systems, are under such stress conditions. Let's just look into the example of India, and what shows us a river system under severe stress is when the water abstraction is above the total annual renewable resources, and this is the case when almost all water can be stored or pumped somewhere, including flood events. And this is a table from this publication here, which shows us the river basins of India, and which shows us here a column of the average annual flow, and in the other column, the utilizable flow annually. Now, what we can see here is, just picking a few cases here, that several of these rivers, or I would almost say most of these rivers, are overcommitted. There's much more infrastructure in place to store water than actual water is available. In some of the cases, it's very, very extreme here, like in those two cases here. Now, what this means also is that water development essentially has been set equal to setting up structures to abstract water. And only in recent years now, regeneration, restoration, reactivating of ecological functions have become thoughts, and trials are going on worldwide and have been incorporated into water development as well. Now, let's look into these feedback loops in stressed rivers, and we can look at this from two angles. One angle is that we increase the water resources scarcity, and what we do on our side is that we try to find better technical solutions to ease this water resource scarcity. We allocate or reallocate economic resources for that, and this comes along with a price, which usually leads to an increase in the costs, increase in the price, which still sharpen or keep on increasing the water resource scarcity, and the cycle goes on and may spin faster and faster and not take us out of the actual problem of not having enough water available at all. And the other obstacle here is not water quantity, but water quality, where we see, because of the water scarcity on this side, we see that water pollution is building up. And again, our way of dealing with this is finding new technical solutions, allocating finances, economic instruments to it, which usually lead to an increase in costs also in terms of additional resources like electricity. And again, we are not solving our water pollution problem, we just adding to it, building it up, concentrating it higher and higher, and again try to find technical solutions to that. So what is the response to this? Water users engage in a race for reallocation or appropriation. And the losers to this circle, those both circles, are the environment and those who cannot afford, the poor in general. So this is not meaning industries or governments on its own. Water users and also mean individuals like myself or you listening to this course. Now, both of them are very negative feedback loops and also traps. So we can't get out of these traps. We are reinforcing instead those negative feedback loops. So the task of our generation is to change this into a plus, into a positive feedback loop where we can move ourselves out of the trap and change the scenario. Now, what are our current adjustment strategies to stressed and closed river basins? Our current adjustment strategies are three only: water conservation, water allocation, and water development. And I found this very comprehensive and useful picture which compiles all these details. We have conserving adjustment here, we have allocation here, and we have developing here. And the center of this is the response to basin closure, to basin stress. And we have several levels which can be institutional or policy oriented or government oriented. And we have the green cycle, which looks into the crop changes in looking into tapping groundwater or into improving on irrigation or improving in water supply technologies. So in the various parts of allocation, development, developing and conservation. Now, obviously this has to be going across temporal and spatial interconnectivity and across those two scales of the hydrological processes and the governance or policy-oriented decisions that can be made in those three fields. For example, cloud seeding may be seen as the solution to water scarcity. We can artificially initiate precipitation, rainfall events, localize to increase our water availability. But this again will be water that is lacking then in some other parts of maybe the same river basin or the neighboring country. Or we may introduce subsidies for drip irrigation, which then may not be, the technology may not be applicable in the environment, the natural environment, water quality related to this, or the level of education of people knowing how to work with such a technology may not be available. So this goes across the various levels here and scales, and for that reason one may trigger a reaction or response somewhere else on the other side here, where we may even not have expected it when we implemented some measure to the best of our knowledge. Now, what are the large drawbacks of these adjustment strategies? They actually sound good, but they will not take us to a solution. And this is because they are not effective in closing or closed river basins, because we simply redistribute spatially our resources, water. We are not increasing the control. We cannot increase control over where water is and in which condition we and what time we receive our water and have it available. And it does not have any influence on changing amounts and quality of water. So those are the major drawbacks which, after taking a close look, actually put water conservation to something that we can call a paper savings exercise, because the losses to one user are return flows for another user. So what one farmer is saving and doing well in terms of water conservation, the neighboring farmer, by pumping more, abstracting more water, or applying more water on his or her fields, increasing evaporation, may benefit from the loss on one side. So it's on one hand side, from a hydrological perspective, not conserving any water at all. We are not having overall more water available, and it, from a government or a governance perspective, very often also is not supporting water conservation, because as this farmer may take less water to reduce losses on his side, he may be punished by only getting a lower amount of water allocated next time when water allocations are made. So this is very often backfiring, and indeed simply a paper saving. Another example is that we may save water by introducing a water saving technology, for instance drip irrigation, but at the same time we expand our irrigated fields if the land for such expansions is available. And all of the effects of water conservation are immediately offset by this. We may not be doing it within our own territory, but then it may be happening in the downstream country, the downstream district or administration of that same river basin. And remember what I've repeatedly said, that groundwater is not an additional stock, although one can read this very often even in the scientific literature as part of the adjustment strategies to work then with groundwater, but it's not an additional stock, we know that. So which means that farmers who do not irrigate, use the water to irrigate their fields, but sell the groundwater to another consumer, still use one and the same amount, source or stock of water and do the same damage. Now, this takes us to a phrase that was coined by this group of researchers, and which brings it down to this essence of it. And that's why I'm quoting it here. It recognized or not, desirable or not, compensated or not, the transfers of water often amount to robbing Peter to pay Paul. So within one and the same river basin, or if we're not talking about a river basin, but at our global water cycle, it is, if we are saving on one side, we are only taking away from the other end of it. Or what we release on this, we will be adding as a punishment to, because we are polluting, to the other end of it. So keep this in mind, and you may want to read more about this in the literature. You should find river basins which are under stress conditions, for example in Asia, and find out what is going on about these situations. I'll see you next time for the next class.